Cool. So, hi everyone. Again, I know you can read it, but I'm Sierra.
I'm Brooks.
I'm Priya.
And I'm Luke.
And we are Scuttlebus. So, the Philadelphia School District is the 8th largest school district in the country by enrollment, with over 203,000 students. Now, most of those students are able to get to school either by walking or taking public transportation, but 40,000 of those students need to take a bus. Now, those 40,000 students attend over 600 different schools. So to figure out how to get those students from their bus stops to their schools, the school district hires 3 different routing analysts, and they make their bus routes completely by hand. So because this process is manual, they're not able to leverage the school district's resources as efficiently as they possibly could. So what ends up happening is that the school district has more bus routes than they do bus drivers. So some bus drivers have to cover 2 routes in one morning. So what ends up happening is the students that are on that second route get to school up to 3 hours late. And every day this happens to about 300 students. So what we want to do is we want to get every kid in Philadelphia to school on time so they can get the quality education that they deserve. So to do this, our goal is to minimize the number of buses required to transport all of the students to school. Now, whatever solution we developed had to match design constraints from the school district. The first one being that the bus ride for any student could not be longer than 2 hours. The second one being that the solution had to be easy for the routing analyst to manage and use. And third, the solution had to be within the school district's budget.
We considered 2 possible solutions to this problem, tiering and bus scheduling. Both solutions reduce the total number of buses used, but tiering is also good because it satisfies the special ed requirement.
Priya?
Yeah, can you hear me?
I can.
We can hear Priya, but I think Sierra is frozen and she was trying to say something.
I'm good now.
Okay, I'll start the slide over. We considered 2 possible solutions to this problem, tiering and bus scheduling. Both solutions reduce the total number of buses used, but tiering is also good because it satisfies the special ed requirement, which requires that special ed students be picked up directly from their house and dropped off directly to their school. It also requires no change in routine for the students. They'll be picked up from their bus stop and dropped off to their school. However, the tiering algorithm is computationally expensive and requires new software, which might be hard for the school district to adopt. The other solution, neighborhood busing, involves creating a system that buses all students to their neighborhood or local school, and once they arrive there, students heading to a different destination school will board a different bus to be taken there. This solution would be technically easy to execute, but does not satisfy the special ed requirements. It also would be disruptive to the daily routine of the students, as they now would have to take 2 buses to reach their school. We decided to implement the tiering algorithm because it was more feasible for the school district to implement. Before we get into our solution, we want to show the system the school district currently uses. As you can see here, the purple shapes identify the stops in school for school 1, and the blue shapes identify the stops in school for school 2. In the school district's current system, 1 bus serves 1 route, as depicted in the diagram, and buses are not reused. This diagram showcases the tiering solution we implemented. Here, 1 bus serves both the purple and the blue route. A bus picks up kids from school 1, drops them off, then picks up kids from school 2, and drops them off. Students from school 1 and 2 are not allowed on the bus at the same time. This diagram depicts an extension of tiering, mixed load routing, that we also implemented. In classic tiering, students from school 1 and 2 aren't allowed on the bus at the same time. However, in mixed load routing, they are. A bus driver picks up kids from schools 1 and 2, drops off the school 1 kids, then picks up some more kids from school 2, and drops them off at school 2.
So Priya just described what tiering and mixing are at a high level, and now I'll give another high-level description about how we implement that within our software to tier and mix routes. So we start off by taking input data from the routing analyst, such as stop addresses and bell times. After that, we process and save time travel data between appropriate points to run our software. Then we run a dual tiering and mixing algorithm that we'll describe in more detail in the demo video. But the outcome of this tiering and mixing algorithm is that we output a CSV. Down the line, this CSV can then be uploaded by the routing analyst to their current routing software, Compass, to better inform the routes that they use. So in order to demonstrate our results, we ran our algorithm on a subset of 4 schools, which each had on the order of about 100 stops. So this picture to the right shows some of the tiered routes from this run. If we look at the bottom left-hand part of that picture at those green dots, we can see that the bus first runs for the St. Martin schools and then travels until it drops them off, and then it starts to go to the red dots, where it serves a route for the Commonly Watson stops. In this run, we achieved an average runtime of about an hour for the non-tiered routes and an hour 45 for the tiered routes. But remember that the tiered routes include 2 routes that are concatenated together. And this is kind of cool because we set the max ride time for this run at 2 hours. And it produced routes that were significantly less. The algorithm took 28 seconds to run, but we could make it faster or slower, trading off the quality of the result. Additionally, on a set of mixed schools, we achieved a runtime of 18 seconds for about 100 stops each to create mixed routes and bus schedules for those 2 schools. When we were developing this project, there were a couple standards that we had to adhere to. The first was ethical. We were dealing with the school, or with the stop data for each of the students, which sometimes corresponds to their home addresses. In order to protect the students' privacy, we made sure to adhere to the GDPR standards for privacy. Specifically, we keep the minimum amount of data that we need in order to run the algorithm, and we'll remove data as they become obsolete. So if the student graduates or moves, we'll delete their entry from the database. Additionally, to facilitate the development of the project and satisfy the needs of our client, we adhere to the ISO IEC IEEE project management standards. So specifically at the beginning, we spent a long time at the beginning of the project trying to understand the specific issue and the cause of the problem that we were seeing that Sierra mentioned earlier. And then after we had that, we tried to design the project in a way, or in a modular way that let us collaborate easier, and will make it easy for others to improve upon it in the future. So that's a high-level overview of our project. We'd like to invite you to watch the video and answer questions from there.
Yeah.